All right, let's get into it. We're going to take a trip, an incredible journey right into the heart of our solar system to explore the sun's atmosphere. Now, if you're picturing just a calm ball of fire, think again. We're talking about a series of violent, mysterious, and unbelievably powerful layers, and each one has its own secrets to tell. So let me ask you this. What do you actually see in your mind's eye when you think about the sun's surface? Is it just a smooth, boring ball of fire? Well, the reality is so much more complex and, frankly, way more violent and fascinating. Let's kick off our journey at the one part of the sun we can actually see from here. Okay, so our first stop is that blindingly bright surface we see from Earth. This is called the photosphere, and you can think of it as the foundation of the sun's entire atmosphere. You know, what looks like a solid surface is really just a layer of gas. And get this, it's incredibly thin. We're talking only about 400 kilometers thick. Now, that might sound like a lot, but compare that to the sun's radius, which is almost 700,000 kilometers. It's this razor-thin layer that gives the sun that sharp, clean edge we see in the sky. Kind of wild, right?
So what's this layer actually made of? Well, no big surprise here, it's just like most stars, overwhelmingly hydrogen and helium. I mean, everything else on the periodic table, it barely even registers, just a tiny, tiny fraction of its mass.
Okay, here's a fun little inside joke for you, something astronomers do. When they're talking about what a star is made of, you've got hydrogen, you've got helium, and then you have, well, everything else. Seriously, they just lump all the other elements together and call them metals. It's this simple, maybe a little funny shorthand that just, gets the job done. You ever notice in pictures of the sun how the center looks way brighter than the edges? There's a name for that. It's called limb darkening. And it's all about perspective. See, when we look right at the center, we're actually seeing deeper into the photosphere, where things are hotter and, brighter. But when we look toward the edge, the limb, our view doesn't go as deep. We're only seeing the shallower, cooler, and dimmer layers of gas. It's really just a simple trick of geometry, but the effect is pretty brilliant. And trust me, this surface is anything but calm. When we get high-resolution images, we see this incredibly violent, boiling pattern. It looks like it's covered in these features called granules. And what you're seeing are the tops of these enormous convection cells, just bubbling up, carrying heat from deep inside the sun. And this is where the scale just becomes mind-boggling. Each one of those little bubbles, those granules, it's about the size of Texas. But it only exists for maybe 10 minutes before it vanishes and a new one pops up in its place. The entire surface is just constantly, violently churning. Okay, let's move up. Rising just above that boiling surface, we get to the next layer of the atmosphere. And this one's usually invisible. It's the mysterious and colorful chromosphere, what you could call the sun's ring of fire. So, the thing about this layer is that we almost never see it. The photosphere just below it is so blindingly bright that it completely washes it out. The only time we get a good look is during those precious, fleeting moments of a total solar eclipse. That's when it pops into view as this absolutely stunning reddish ring around the blacked-out sun. And this layer, the chromosphere, has an amazing story. Get this. Back in 1868, during an eclipse, astronomers were looking at its spectrum, and they saw this weird yellow line, a color of light that didn't match any element they knew of on Earth. So this one scientist, Norman Lockyer, made a bold guess. It had to be a new element. He named it helium, after Helios, the Greek sun god. And the craziest part, it took another 27 years before anyone actually found helium here on our own planet. We discovered it on the sun first. So here's the key thing to understand about the chromosphere. Unlike the photosphere, which is all about boiling gas, this layer is completely dominated by the sun's powerful and super complex magnetic fields. These invisible forces are grabbing the gas and twisting it into these incredible structures. Things like those bright patches called plages, or the enormous looping prominences that arc out into space, and even these fiery jet-like things called spicules that are constantly shooting upwards. All right, we're traveling even further out now, to the sun's final and honestly most mysterious layer. This is the ethereally beautiful, ghostly faint corona, which literally means crown. Okay, first, let's just reset our baseline for a second. Remember the temperature of the photosphere, that surface we started at? It's about 5,700 Kelvin. Pretty darn hot. Okay, now get ready for one of the biggest shocks in all of astrophysics. The corona, which is farther away from the sun's core, is blazing at an unbelievable 2
million Kelvin. I mean, it is hundreds of times hotter than the surface right below it. How is that possible?
And that question right there, that brings us to one of the greatest unsolved mysteries in all of solar physics. It's called the coronal heating problem. Think about it. It's like standing way back from a campfire and feeling hotter than you do when you're right next to it. It makes no sense. It just defies logic. How on earth does energy from the sun's core somehow jump over the cooler surface to superheat the outer atmosphere? We still don't have the final answer to that.
And it's kind of like the helium story all over again. For decades, scientists saw this weird green light in the corona spectrum and thought, hey, it must be a new element. They even named it coronium. But it wasn't. It was just good old iron, but iron that had been cooked so intensely to millions of degrees that 13 of its electrons had been ripped away. And that was the proof of those impossible temperatures.
But you know what? Our journey doesn't actually end there. The sun's atmosphere is so ridiculously energetic that it doesn't just stop. No, it extends its reach all the way across the entire solar system. Basically, the corona is so incredibly hot that the sun's gravity just can't hang on to all of it. It's like a pot of water boiling over. A constant stream of charged particles, protons and electrons, literally boils off the top and goes flying out into space in every direction. And that is the solar wind. And the amount of stuff the sun is losing here is just staggering. I want you to really think about this number. Every single second, the sun loses about 100,000 tons of its mass. That material just becomes the solar wind streaming out through the solar system. Now, I know what you're thinking. That sounds like a lot. But before you start to worry, let's put it in perspective. It's really just a cosmic drop in the bucket. Over its entire 5 billion year life so far, all that mass loss adds up to less than 0.01% of the sun's total mass. So yeah, our star is in absolutely no danger of fading away anytime soon. And that brings us right back to where the biggest mystery is. From that seething surface all the way out to that ghostly, superheated crown, the sun's atmosphere is just a place of truly impossible physics. And the question that remains, the one that still keeps scientists up at night, is this. What is the unknown mechanism, the secret engine that carries energy from deep inside the sun, skips right past its cooler surface, and dumps it into the corona to create that insane heat? Solving that one puzzle might just unlock some of the biggest secrets about how all stars work.